Okay, so let's move on. Let's talk about the tools a little bit, and what are the tools that we have in our bag, and what can we do to deal with them. So start out with SystemC comes with a built-in report handler. We have messaging levels and we have verbosity, right? So stop using printf and stop using standard cout. All right, there's two reasons for doing this. Actually, there's several reasons, but the major reasons are, one, I/O is one of the single largest determinants of slowing down performance in your simulations. This even affects folks doing Verilog, VHDL, and so forth, but let's focus on SystemC here. So instead of using those two, always use the SystemC reporting mechanisms, such as this example here, the SC report info verbosity. And then if you have debug messages, you don't want them running all the time, just when you're debugging. So label, set the verbosity on the message and say, oh, it's a debug level message. All right. I'm not going to explain all the arguments to these things. I'm assuming everybody watching this has some exposure to SystemC, and if you don't, please go get some training. I promise it's going to be worth your time. The next one is the message type in those report messages, that first argument in the SC report info and your SC report error and warning and all those messages from SystemC. They're supposed to be like an identifier, a tag, an ID, if you will, for what the message is related to. And generally, it tends to be very file specific. So what I do is I put a single constant. I always call it MSG_type, and I place it in, and it's got a fixed format on each file, basically, or each class has one of these, right? And occasionally you have to put a couple in there because there may be some variation, but it'll save you a lot of time, because you can. One of the things you can do is you can actually not make typos when you're putting these in, and stop the repeating yourself. Use the drive principle of programming. Do not repeat yourself, right? And then learn how to configure and filter messages when you're running the tools, right? And you're gonna build some of that in. So let's go a little bit further here. Let's think about adding, in terms of just configuring and filtering. There's also, you might want to consider some extensions in your code somehow for convenience. I'll show you some ideas about that here in the next slide. All right. So first off, create some static functions for use during debug to display, for example, the current simulator state. Are we doing an elaboration, or are we running? Hopefully most of the time we're running. What's the current SystemC time? And for that matter, if you're doing the temporal decoupling, what's the decoupled time? And what's the thread we're in, or the method we're in, right? Do something like that. And so that within a debugger, and our focus in this talk is going to be on GDB, just because we had to pick one, and it's probably the most ubiquitous debugger out there. So in GDB, I can say call debug call info. That's a class. It's a static method that I've got that dumps out some useful information. And I have several of these for different kinds of information, and you can use these in your classes. By the way, you'll have access to the code. We'll send you that information later on how you can get to that, so you'll be able to go take a look at how I've done it. You might not like exactly what I did, but you can at least have a starting place. So how do you catch error messages? And this has to do with the filtering I was just talking about on the previous slide. One of the things you can do is you can say, look, anytime I do report error, that is to say, I have a message of type SC error, I want to display it, log it, but the last thing on this slide is really important here. I want to have it call another method called basically interrupt here. It's a function inside of SystemC that you can cause the report handler to stop at, and you put a breakpoint on it inside the debugger, and that's very useful, it turns out. And you can do that for any kind of messages. Another thing is you need to figure out, how are you going to change the verbosity? Well, one of the things that'd be nice is maybe at the command line, you can add a -- debug when you run simulations that need debugging. That's certainly convenient. But by the way, you might also want to think about that call debug info. How about a call debug debugging, or set debugger, or to change the verbosity while you're debugging, and be able to not just change it on, but change it off. Maybe you have a simulation that has long periods of time between things, and you just want it to run faster. Okay, so those are useful. And so I've created a little debug.cpp and the header file that goes with it. That's my debug support, right? Those functions that I put in there to directly support things inside of GDB. Now, waveforms are another way to capture information, and people jump to that really quickly. Sometimes there's a couple of different types of wave tracing, though, and you need to think about that because waveforms is a form of tracing. I'm grabbing all the data, right? But you need to be very selective about it. You only want to use it as needed. So, in addition to that --debug, how about a --trace argument to say turn on tracing so that tracing's not turned on all the time? Again, it can affect performance a little bit, and you only need it. And you can even be more selective than that. And what I'm going to show you, I don't have that, but you can be selective to say, I only want to trace this certain module, and be able to select that at the command line, or maybe be able to turn that on or off inside the debug. Those are things you might want to think about. Maybe runtime configuration for the waveforms. Maybe you can deal with that. Or data tracing. That's actually a feature. GDB supports this idea of running simulations. You're not setting breakpoints, but instead you actually tell it to trace certain variables. And some of the processors have hardware support for this, some don't. Doesn't matter. It's much faster, though, than having breakpoints and some of the other mechanisms that we previously used. But please be careful when tracing and thinking, well, I'll just trace all the information. You can waste a lot of time collecting the data and then trying to analyze that data. You need to be methodical. You need to go back to those 13 steps. You need to carefully place and word your debug messages. Okay? Don't get sloppy about that. Sometimes you just say, oh, is there an error here? And you put, oh, error detected or something like that. You want information about why, or any information you can have that might help someone to understand why the error is occurring and where it's occurring. And that's a benefit of the SystemC report mechanism, too. It puts out some extra information when you have errors and warnings. And then finally, any coding change you make, you should rerun the tests, right? Because you make a change to the code of any nature, the bug might appear to go away. Now, that may or may not be a good thing because you need to know whether you understood why it went away. So if you tried to make it go away and then it didn't go away, that's one thing. But what if you are just, I want to get a little more information out. I add a few lines and all of a sudden the bug goes away. There's a problem. Okay, so we're going to focus on GDB, the GNU debugger. And this thing is used everywhere. In fact, often underneath commercial tools. I'm not going to focus on which tool. Sometimes it's really obvious. Sometimes it's not so obvious. But what I've discovered is most programmers actually never read the manual. Now, I have actually read the manual. At least once very seriously, because I ended up having to debug about 11 million lines of source code using just GDB and brains. The story's long behind it, but the point is, when I read it, I was surprised. There are all kinds of features in there, and the basic concepts of just putting in breakpoints and putting out values, those are useful, yes, but there's tons of great features in there. Now, GDB has moved on, by the way. It continues to mature. It was started back in '86, and I hate to admit it, but that was actually, I was already a practicing professional at the time when it was introduced. But anyway, the latest version is 14.0. What version do you use? For preparing for this demo, I've used variously 9.2, which was found on Ubuntu 20.04, and then I discovered that on Ubuntu 22, I think it's 22.04 that I was using. I would get 12.1, I believe, is what I used in the demo in terms of things. So don't use an ancient version of GDB. I've seen people using version 4 and other things like that. That's just not good. Now, by the way, GDB is not available everywhere. If you're on a Mac and you can do SystemC development there, I do it all the time. You have to use LLDB. That's an alternative. Now, I chose this lecture to be GDB because that is the most prevalent debugger out there. LLDB has some great features. There are other debuggers as well out there. And we'll talk a tiny bit about that towards the end. Okay, now, GDB itself has the ability for you to define what are called user commands. And one of the things I've done, this is an excerpt, although I've actually changed this up quite a bit since I put this together, but it's, I'm defining a little command called SystemC. that does some things. Now, my current version of SystemC actually loads a bunch of other things at this point. But the ideas behind what's in this particular slide are pertinent. First off, set up a breakpoint. Oh, by the way, that first line there, breakpoint pending on, has to do with the idea that I don't have to be running a program when I set my breakpoints. GDB can, be pending or whatever. Then maybe I want to break on the top level constructor. Notice the naming convention I told you I was using. The next two, interrupt here and stop here, well, those are places I want to set breakpoints on because I configured my errors in my code to break on the SC interrupt. And also, if I do SC, if the error message is a stop the simulation, they'll drop me into there so I can take a look around. And then what I did over here, so you look, well, we'll get to that here in just a second. Breaking on wait. That's when your module suspends. Break on SC module wait. Although it turns out it's trickier than what I'm showing here, and we'll talk a tiny bit about that in a little bit when I'm doing the debug demo. GDB also has regular expression breakpoints, and that's why that naming convention is so important here. So here I'm saying I want to put a breakpoint on the initial initiation of every one of the threads in my code. And so I had that uppercase, lowercase, and then underscore thread at the end. Or I want to break on the one right below 6 there on the left. This one down here, this is breaking on start of simulation, end of simulation, before end of elaboration, those kinds of things. And you may want to be more specific than this. This just kind of fits in here. And now, commands here. What this is I put a 3 and a 4 after it, which specifies the third. So when you put a breakpoint out, it'll actually give you back a number. So breakpoints 3 and 4, which happen to be those interrupt here and stop here, I need to do something special. For example, I want to take a look at a backtrace when I hit those things to see what was going on when it hit the error message. And then I may do other investigations, but that's one of the things you could do. Another thing you can do is I put one here on 5, is that anytime I see a wait, I'd like to just put out some information that a wait occurred. Right? I may want to do more than what's here. This is a simplistic approach, but the idea is good. In C++, we have exceptions. And so if you want to catch an exception when it's being thrown, or do you want to catch it when it's being caught? You have both of those options. And then finally, very important thing here, we can sell the SystemC to skip anything that's inside the SystemC library or the TLM library, and there's other things like the standard library you may want to skip because you're not debugging that stuff. And if you have somebody else's code, you may want to skip their stuff as well. So these are things that you want to go deal with.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of David's webinar, Debugging SystemC with GDB, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the KnowHow area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.